Hello everyone. Today our group would like to give a presentation on the von Neumann architecture. I am Lavanya, index number 216046F, and I will do the brief introduction about the von Neumann architecture. The computers in the early years used fixed programs such as modern calculators. This changed with the invention of the stored program computer. The theoretical design for stored program computer known as von Neumann architecture created by physicist and mathematician John von Neumann in 1945. And this architecture is also referred to as the von Neumann model or Princeton architecture. This is still using as the primary foundation of majority of modern processors. In this architecture, both instructions and data can be stored in one memory, and the memory is divided into equal-sized compact cells with the unique address numbers, and using this architecture, commands can be saved as binary number format in computer memory. Von Neumann architecture contains 5 basic components: a processing unit containing both process registers and an arithmetic logic unit, a control unit with a program count and an instruction register, memory for storing information and data, widespread external storage, techniques for both input and output. One of the main parts of von Neumann architecture is the fetch, decode, execute cycle, which has 7 stages, and in this computer architecture, main memory has stored both data and instruction, and they are fetched on at a time from RAM to the processor. Von Neumann architecture has shown to be extremely effective for a variety of reasons. Von Neumann machines are deterministic and introspectable, and they are comparatively simple to implement in hardware. They are understandable at every stage of their computation process and are accessible to mathematical description. Furthermore, you can rely on them to consistently produce the same result from a single set of inputs. Everything has limitation. Also, we can identify 2 main limitations. There are von Neumann bottleneck and self-modifying codes. Currently, computer architectures found the solution for these limitations as well. In this report, we are going to discuss further information about von Neumann architecture. Over to you, Navodya.
Thank you, Lavanya. I'm Navodya Fonseca of index number 216036B. Next, I will talk about the history of von Neumann architecture. Von Neumann architecture, which is also known as the Princeton architecture, was built by scientist and mathematician John Louis von Neumann and by others in the first draft of a report on the EDVAC in 1945. EDVAC refers to Electronic Discrete Variable Automatic Computer, which is one of the original electronic computers. Almost all modern computer designs are based on ideas created by John von Neumann. John von Neumann, who is known as the father of modern computer, is a nobleman born in Hungary. A lot of computer scientists and von Neumann worked together, and in the mid-1930s, he met Alan Turing and learned about Turing's plans to create a computer that could store data. This interaction would inspire the von Neumann architecture, according to the biography by von Neumann. While working at Moore School of Engineering in Philadelphia, von Neumann initially penned a report on the suggested digital designs of a computer. In this work, von Neumann would present the initial design of these computers. In order for computers to be programmable and reprogrammable, this model suggests how they should operate. Von Neumann, Burks, and Goldstein offered a more detailed description of what would later be known as von Neumann architecture in a 1946 paper titled Preliminary Discussion on the Logical Design of an Electronic Computing Instrument. Primitive machines were designed with specific jobs and specialized operations in mind, like algebra. Machines could not be rewired since their programming was built into their designs. They could only be manually dismantled and rebuilt. The von Neumann model brought a change in this. Once implemented, machines built using von Neumann architecture could be changed and programmed by entering instructions in the programming code. As programming languages advanced, this made it possible to rewrite computer functions. Over to you, Hiranya.
Thank you, Navodaya. I am Hiranya Monisingha. My index number is 2161333U. So I will be talking about the basic structure, modern microprocessor-based computer systems, and the attributes of von Neumann architecture. The basic structure of von Neumann architecture. This model is the basis for most of the computer programming languages. It contains a single central control in the central processing unit, as well as a specific storage area called the main memory. Communication allows the CPU to access locations of commands and operands from the primary memory. Data has to be retrieved from primary memory and transferred to the CPU since it also houses the arithmetic logic unit. CPU has a register bank which functions as a sort of scratchpad. Next, I will explain how this process simply works. Von Neumann computers work primarily on the basis of a flowchart. An input device is first used to enter certain data or instructions. Following that, central processing logic unit and as many register units as required are needed to process the input. Then those data are kept in a storage device. Once a computer receives the proper inputs, a program is launched, and the outcomes of that program will be shown on an output device. Next, I'll be talking about modern microprocessor-based computer systems. The fundamental physical elements of a modern computer are divided into 5 units: memory control unit, arithmetic and logic unit, input and output devices. A computer works by its CPU carrying out the instructions to process the data. Von Neumann architecture laid the groundwork for the first programmable computer. Its design relies on holding both programs and commands in one primary memory unit. As a result, computers can function far more rapidly and effectively. Next, I will be talking about the attributes of von Neumann architecture. First one, the fundamental role carried out by a computer is the accomplishment of a program that concerns implementation of an instruction that provides information about an operation, data on which it is to be implemented. Second one, the processing speed can increase with the magnitude of the register. Third feature, a computer needs a bus system to move information internally. The bus system is one of the connecting structures. The last feature is both data and instructions are kept in an equivalent memory unit for implementation in this structure. Thank you. Over to you, Anali.
Thank you, Hiranya. Hello, I'm Manali Fernando of index number 2160334R, and I'm going to talk about the components of von Neumann structure. The von Neumann structure consists of 3 main components as the central processing unit, memory unit, and input and output devices. The central processing unit, which is also known as the brain of the computer, is a piece of hardware that executes the instructions retrieved by a computer program. Also, the CPU can be divided into 3 parts as the control unit, arithmetic logic unit, and registers. The control unit retrieves the instructions from the main memory of the processor and identifies the devices and actions involved and generates control signals and carries out the relevant operations. Next, the arithmetic logic unit. It is a digital circuit that performs all kinds of arithmetic and logical operations on the operands. It consists of 2 parts as an arithmetic unit and a logic unit. Next, the registers. Registers quickly accepts, store, and transfer instructions and data that are immediately being used by the CPU. Accumulator, data register, address register, and the program register are some examples for registers. The second main component is the memory unit. It is a collection of storage cells that are used to store data and instructions in a computer. It stores binary information in the form of groups of bits called words. Computer memory is classified into two types as primary memory and secondary memory. Primary memory contains the data and instructions that are being executed presently by the CPU and stores data or instruction temporarily. Also, primary memory can be divided into two parts as random access memory and read-only memory. The secondary memory is the device which stores data and information permanently. Magnetic tape, hard disk, DVD, and memory cards are some of the examples. Next main component is the input and output devices. Using input devices, the data and instructions are fed to the computer system, and output devices receive data from the computer and then translates the data into a human perceptible form. Mouse, keyboard, and scanner are examples for input devices, and printer, monitor, and projector are examples for output devices. Thank you, and over to you, Vinod.
Thank you, Anali. I'm Vinumi Nuhansa of registration number 216088J. I'm going to talk about the fetch execute cycle. The fetch decode execute cycle, also known as the instruction cycle, is considered as an important model out of the models of computation. This shows the basic principle of how all modern processors work and has remained the same since the days of von Neumann architecture to today's supercomputers. From the moment the computer is turned on, with the effects and involvement of other registers, the computer executes program until the shutdown of the machine. When a computer is turned on, fetch cycle, decode cycle, execute cycle is gone through repeatedly. The fetch cycle begins with retrieving the address stored in the program counter. This address will be holding the instruction to be executed. The memory address owned by the program counter will be copied to the memory address register. The memory address in the memory address register receives a signal from the processor through the address bus. The instructions which were in the memory address will be delivered to the memory data registers through the address bus. The instructions which were in the memory data registers will be copied to the current instruction registers, which is made up of data component operand and instruction opcode. The content owned in the current instruction registers will be sent to decode and execute. Results and outputs of the processing will be stored by the accumulator. The decode unit has a set of instructions that specifies the opcodes and consequently the commands to execute. The execute unit, which includes an arithmetic logic unit, executes the proper instructions based on the data operand. Now the address within the program counter will be increased by 1 and will have the address of the next command. Then the cycle returns back to step 1 and the whole fetch, decode, execute cycle is restarted. And so on, this cycle continues by fetching and executing commands until the shutdown of the machine. Next, Sasini will talk about the evolution of von Neumann architecture. Over to you, Sasini.
Thank you, Vinui. I'm Sasini Dabara and my index number is 216019C. So in my part, I'm going to talk about the evolution of von Neumann architecture. In first, early von Neumann architecture computers. The von Neumann architecture started in 1948, changing from time to time. For this development, new research has been done by various universities and computer scientists. These type of computers evolve from age to age and have their features. First, ARC2. This type is called Apex, and this computer structure is found by Andrew Donald Booth. Manchester Baby. This computer structure was introduced by Frederick C. William, Tom Kilburn, Geoff Tootle at University of Manchester in 1948. Edward. This type launched by Moore School of Electrical Engineering, Pennsylvania. The next one is Odrak. This type is the first structure that had a compiler, and this was assembled at the University of Illinois in 1951. IAS machine. IAS machine was an electronic machine developed by John von Neumann at the Institute for Advanced Study in 1952. With that, this type was introduced by Israel in 1955. In the next, the stored program computer concept. The stored program computer is a computer device that stored command inside the computer storage, enable to the use variety of activities linear or regularly. John von Neumann first presented this concept in 1940. He suggested that commands be mechanically stored in binary number format in computer memory that may updates based on primarily computing findings. The first stored programming computer is the Manchester Baby in 1948. This memory contained both data and instruction, and they could be changed automatically through calculation digital speed. Evolution. From 1950 to 1970, the computer structure grew exponentially to guide the evolution of von Neumann architecture. After 1970, computer scientists focused on reducing the cost and the size of computer system. Over to you, Mevni.
Thank you, Sasini. I'm Muni Basnaka of index number 216016N. So I'm going to talk about the capabilities and the limitations of von Neumann architecture. First, we'll move to the capabilities of von Neumann architecture. The capability to consider the instructions as data decides the existence of components such as compilers, assemblers, loaders, and linkers. This situation enables the creation of programs that write programs. Because of this, the advanced self-hosting computing ecosystems has developed in relation with the machines with von Neumann architecture. After that, we'll check what are the limitations of von Neumann architecture. The two special limitation designs can be seen in von Neumann architectures, can be mentioned as follows. Von Neumann bottleneck and self-modifying codes. Von Neumann bottleneck. In von Neumann architecture, both the program memory and the data memory use a shared bus. So the shared bus deals with two levels of memory. As the data and instructions can be captured by the memory in sequential order, the data transfer rate among central processing unit and memory becomes limited. So this is known as limited throughput. When the data transfer rate among the memory and central processing unit is lower than the processing rate, the machine can't fully utilize the processing power of CPU as CPU forces to wait for data. When the processing speed of CPU increases and the size of memory becomes larger, the effect of throughput increases. The situation can be defined as von Neumann bottleneck. The American computer scientist John Warner Baker first described von Neumann bottleneck in ACM Turing Award lecture in 1977. Self-modifying codes. The codes which change its own codes during the time of execution can be defined as self-modifying codes. Usually, this method is used for shortening the instruction path or reducing the repeated code. The performance of the machine are enhanced because of the technique. When it comes to von Neumann architecture, either by designing or by accidentally, self-modifying codes can be harmful. Malfunctioning programs can be harmful to themselves, other simple programs, as well as the operating systems, and can make path to a computer crash. Then I'm going to summarize the points we discussed in this presentation. So as conclusion, we can state that von Neumann architecture was invented by John von Neumann in 1945. The three main components in this architecture are the central processing unit, memory unit, and buses. The fetch execute cycle is a significant model that comes under von Neumann structure. Since 1948, the concept of von Neumann architecture has been evaluated through various observation and researches. Von Neumann architecture has been modified with the introduction of the stored programming concept. The von Neumann bottleneck and self-modifying codes can be noticed as two major limitations of von Neumann architecture's design. So that brings us to the end of this presentation. Thank you and have a nice day.